I'm going to present to you one of the applications that is part of our Carrier SDN solution, and it's about path computation element or PCE, and that's really an application that allows you to discover your network topology and to instantiate and manage segment routing TE LSPs and RSVP-TE LSPs using this tool, and also to basically do a number of capabilities, which I'm going to demonstrate today. So this is all based on standards protocols that are being developed by the IETF, the Internet Engineering Task Force. And so basically what I have here on the screen is actually a multi-area network that uses the OSPF protocol. And I've got three areas, a couple of leaf areas and the backbone area. And I'm going to show you basically how to instantiate LSPs and how the PCE will control these LSPs, reroute them under failure condition. And when the link is restored, you can see that you can also restore the original path of those LSPs. So let's go and see what's behind this in terms of the standards protocol. What do you have to do in the controller and on the router in terms of configuration to make this happen? So, so first thing is the configuration is actually fairly simple. On the controller, on the PCE server, what you see here is basically the configuration for the PSAP protocol or the PCE protocol, which is PSAP. This is really just configuring your local address and let it basically discover all the routers in the network. And then, so this is from the perspective of the routers for instantiating and managing LSPs. From a topology discovery point of view, we use the BGP protocol. So there is a BGP session that's established with the routers, specifically the ABR routers, not all the routers on the network. And there's a new type, a new family that was defined by the ITF that's called BGPLS. And this is really what we're going to do. We're going to upload the topology of the network using BGP protocol, using the BGPLS family. And then we are going to basically show you how we can use that topology to compute paths for LSPs. Here at the bottom, I've got the status of this PSAP session. It shows me that it actually discovered, or at least it established a connection with 4 routers. So these are the routers that we're going to show you in the picture here, where we're going to establish the LSPs. So I've got this router here, this router here, this one, and this one. So what you see here, I've got actually 4 paths for LSPs. So I've got basically LSP is label switched path, of course, MPLS LSPs. So I've got LSPs that are going between this node named Las Vegas to this node that's named Detroit. And so I've got one of them only. This is the green color one. And I've got a couple or 3 LSPs starting on a node called Reno here and going to node Atlanta. Now, what you will notice at the bottom here, you've got all the information that was discovered for this LSP. So the first thing that will happen when that PSAP session comes up is a synchronization of the LSP database between the routers and the PCE server or the controller. So here you see that we've actually discovered our 4 LSPs, and we know the type. So I've got a couple of them that are segment routing and a couple of them that are RSVP. And the RSVP LSP is actually one LSP with a couple of paths. So there's a primary path and a secondary path. So primary path is going straight on the bottom links, and then the secondary path is going on the top links in the core area and then going down on the remote leaf area. And then what is really special about these LSPs is that I have configured them such that they should not be sharing, the top LSPs and the bottom LSPs should not be sharing links in the core area. As you can see here, basically the green LSP and the blue LSP are not sharing any links in the network, and the yellow and brown are not sharing links, the same links in the backbone area. So the yellow one is using the top link, and the brown one is using the bottom link. So what we want to be sure is that once you've established these LSPs with your own constraints, meaning that they are path disjoint or link disjoint, you want to make sure that if there is a link failure, PCE will compute a new paths for these LSPs and still hold to those constraints, and they remain actually disjoint. So let's try it and see if that works. So I'm going to fail this link in the core area, and then we'll see if the PCE will automatically react to this failure and actually compute a new path. And what I mean by that is the traffic for the service provider should not be interrupted. It should be a very hitless operation. So let's see if that works. And that's really the intent here. So I'm gonna go to my OSPF topology and fail a link here. So just fail a link, and let's go back to our picture here. I'm gonna remove the highlight for a moment. So you see the link here is colored in red. So this one here, it means it's actually down right now. So the link is down. What we need to do is to check whether there was an automatic recomputation of those paths by the PCE controller. So let's do that. So it's very simple. How you can do that is you go down to the menu of these LSPs, you highlight all of them, you right click, and you say overlay resource. So that what it does, it will highlight the paths of those LSPs. So we're going to get the new highlights here. And so what you notice is now I've got this link that went down here between Houston and St. Louis. Of course, we can't use it. It's down. So what you will see is the LSPs at the bottom that were using the bottom links have rerouted via the top node, so this router here, but they actually immediately come down to the next bottom node, and they are not actually still sharing links with the top LSPs. So we actually kept that constraint going even under failure. And this is really the advantage of a tool like that. Not only it does automatically detect the failure and will recompute the paths of the LSPs, but you can actually visualize it on the topology, and you can see exactly the result very immediately after. So, so one also of the other really good things about this tool is that you can at any time decide that you want to re-optimize the paths of the LSPs, meaning that you ask the PCE server to recompute the paths. And how you do that is very simple. So let's take an example. I go back to my OSPF topology. Let's say I bring back this link. So I bring it back up. Now I go back here. Let me remove the highlights again. And you'll see now this link is back up. What I want to do is I want to tell the PC server, can you please go back and see if there are better paths for this LSP. Now that this link is back up, I must be able to find the original paths which were the best paths for these LSPs. So when I say best paths, it means the ones that are the least costly from a metric, from a bandwidth perspective, etc., hop count, etc. So let's do that. So still highlighting all these LSP at the bottom, then right click and say overlay resources. Let's see what happened here. So I still have my own LSPs, right? So this is still the paths that were computed after the link failed. But I can go here in one click operation, right click here and say resignal. And once I do that, it will automatically recompute paths for these four LSPs. So let's do that and wait a moment. So it's done now. Now I go here, remove the highlight again, go back here and show the new paths. Right click, say overlay resources. Now what it is showing is basically I'm back to my original topology. Now really this is really, as you can see with a single click, you can ask the tool to recompute the paths of all the LSPs or a subset of LSPs in the network. And it's so simple. You don't have to go to the router and kind of play with the CLI or mess around with your configuration. It's all done from your GUI. It's very simple, very intuitive. Now, what is really interesting is you can do actually more things with this tool. One other example would be, well, maybe I don't want to optimize for the shortest path. Maybe I want to spread my bandwidth, the load balancing of all the bandwidth of the traffic over the network. If I want to do that, this is probably not the best way because I can show you the link utilization. Sorry, here. And let me bring this up a bit. So what you see here is, well, I've got a link that is at 100%. So I'm not actually using this link, so we will ignore it for a moment. But you can see that I've got 4 IP links that are utilized between 25 and 35%. And then all these green links, which are the ones that are lightly loaded, are all around 10%, 5%, and 0%. So it's not really well distributed. What you want is, if you want though, if you want to load balance the traffic, you want to have a better distribution of this load. So let's give it a try. Let's see if we can achieve that. So this tool allows you to do that in actually very straightforward manner. And again, we go back to our LSPs and they highlight all 4 of them. You right click and say optimize, and then you select link utilization. Notice I said originally I was talking about shortest path. What I meant by shortest path is we were actually optimizing based on the shortest cost, which is the IGP metrics of the link. If I said link utilization, that's a completely different re-optimization. So let's click this and let's wait. It's finished already the computation. Let's go back here, um, remove the highlights, show the new paths again by selecting all 4 LSPs, right click and say overlay resources. Now I get the new 4 paths of this LSP. So again, notice that those constraints about disjointness of the links are still satisfied for all those 2 pairs of LSPs, as you can see here. But the difference is that basically the utilization must have improved this time. And to show that, let's go back to our IP link utilization and go up. So what you notice here is that now we've got only 2 links that are used between, well, 25 and 30%, and then we increase it more the utilization of the other links. So we have now green links that are in the 20%, 15, and 10, and basically 5. So we've got more links that are green that are than blue, which means we need a better utilization. And basically, to summarize, this is the path computation element, PCE, is actually a standard-based tool which allows you to uh, discover your network topology using IGP or the BGP protocol with the BGPLS family. Use the PSAP protocol to be able to instantiate and manage um, segment routing TE LSPs and RSVP-TE LSPs in the network, and that tool automatically computes paths. When there is failure, you can re-optimize a subset or all of the LSPs when the topology changes or you are adding more links or you're removing links. And you can actually re-optimize re-optimize the paths based on different constraints, including shortest path or your load balancing of traffic.